Welcome to This Explainer. Today, we're going to bust one of the most universally believed space myths in human history, right out of the gate. So I want you to picture something in your mind's eye for a second. Imagine zooming all the way in on a single microscopic grain of gray lunar dust. Got it? Now hold that image and let's pull the camera back. We're flying up from the cratered surface, zooming out past the orbit of our satellites until we can see the entire breathtaking Earth-Moon system floating in the deep black of space. It's a majestic, totally silent dance that's been going on for billions of years. But in all that time, from down here on Earth, we've only ever been allowed to see one half of our closest celestial neighbor. So today, we are taking a journey to that hidden half.
Okay, let's dive into this. You've undoubtedly heard the phrase before, right? It's literally everywhere in pop culture. It's the title of one of the most famous rock albums ever recorded, and it's an absolute staple of science fiction. The dark side of the moon. It evokes this incredibly mysterious, freezing, pitch-black wasteland where the sun never shines. It sounds terrifying and, let's be honest, pretty cool. But what is actually sitting in the shadows of the moon's hidden half? Is it really a realm of perpetual darkness? Well, I'm just going to be blunt here. The whole myth of the dark side is completely false. The hidden half of the moon actually gets exactly as much sunlight as the side we see twinkling above our backyards every single night. Just like Earth, the moon has a day and a night cycle as it spins through space. Each location on the moon experiences about 2 straight weeks of brilliant, blinding sunlight, followed by 2 weeks of total darkness. To put that into perspective, during the uncrewed Artemis 1 mission, the hidden side of the moon was actually beautifully illuminated by the sun as the Orion capsule flew right past it. So, let's adjust our vocabulary a bit. For the rest of this explainer, we're exclusively going to call it the far side of the moon. You see, when early astronomers used the word dark to describe the moon, they didn't mean unilluminated or lacking light. They actually meant dark in the sense of being unseen or unknown. Before humanity could fling spacecraft into the void, this area was just entirely hidden from human eyes. The term also evolved to describe radio blackouts because when a spacecraft, like the Apollo missions, goes behind the moon, that massive rock blocks all communication, plunging the astronauts into a dark zone. But optically speaking, it is perfectly well lit.
So, the crucial point is, if it's perfectly well lit, why do we only ever see one side? Well, the answer lies in a simple, super elegant ratio. 1:1. The moon rotates exactly 1 time on its axis for every single orbit it makes around the Earth. Think about it. If it didn't rotate at all, we'd eventually see its entire surface as it moved around us. If it rotated twice as fast, same thing. But because its rotational period perfectly matches its orbital period, which takes about 29.5 Earth days, it effectively keeps the exact same face pointed at us at all times. Now, this perfectly synchronized cosmic dance isn't just some wild coincidence. It's a well-known physics phenomenon called tidal locking. If you're trying to wrap your head around how a spinning object can only show one side, just think of this intuitive analogy. Imagine you're walking in a circle around a chair in the middle of a room. If you keep your face pointed directly at the chair the entire time you walk, you'll have faced every single wall in the room by the time you get back to your starting point. You rotated exactly once on your own axis, but the chair only ever saw your face. That is tidal locking in action.
So, how did this whole lockup happen? Well, it's an absolutely epic story stretching back billions of years. When the moon first formed, it actually rotated way faster than it does today. But Earth is massive, and our gravity constantly tugged on the moon, creating literal physical bulges in the lunar rock. As the moon spun, these bulges shifted, which created massive internal friction. This friction basically dissipated the moon's rotational kinetic energy as heat. Over millions and millions of years, this tidal friction acted like a giant set of brakes, slowly grinding the moon's spin down until it reached a point of equilibrium, locking perfectly with its orbit. It's a permanent gravitational embrace. Now, what's really interesting about this slide is, you might assume tidal locking means the moon is perfectly frozen in place, right? But planetary scientists are quick to point out a major misconception here. Because the moon's orbit is slightly elliptical rather than a flawless circle, and its axis is slightly tilted, it produces a fascinating optical effect called libration. This is basically a slight orbital wobble. Because the moon speeds up and slows down slightly in its elliptical orbit, we can actually peek just around the edges from our vantage point on Earth. Over time, thanks to the swabble, we can actually see about 59% of the lunar surface. But, that still leaves an incredibly frustrating, permanently unseen 41% of the moon's surface that we can just never, ever view from standing on Earth.
We've talked about the orbital mechanics and the physics that hide it from us, but what is actually sitting back there? If we could just teleport to the far side right now, what would the landscape look like beneath our boots? Let's shift our focus from the mechanics of space to the gritty reality of lunar geology.
If you actually looked at the two hemispheres side by side, you honestly might not even believe they belong to the same moon. They've got dramatically different appearances. The near side, the one we know and love, is defined by multiple large maria. These are those vast, smooth, dark patches we see from Earth. But the far side? It is exceptionally rugged, deeply battered, and violently cratered. It has almost zero smooth plains. It actually looks much more like the barren ancient terrain of the planet Mercury or Jupiter's moon Callisto. And this brilliantly illustrates just how stark the contrast is. The dark maria cover about 31.2% of the near side hemisphere. But on the far side, they cover a measly 1%. No way, right? Because it lacks those massive expanses of dark, cooled lava. The far side is physically brighter and way more reflective than the near side. It's an incredible irony when you think about it. The legendary dark side of the moon is actually the brighter side.
So why the huge difference? Well, about 4 billion years ago, both sides of the moon took similar beatings from asteroids and meteorites. They both just got hammered. But data from NASA's Grail mission revealed something extraordinary. The crust on the far side is significantly thicker than the crust on the near side. The near side was hotter and had a thinner crust, which allowed liquid basalt, basically lava, to seep up from the mantle and fill the giant impact basins. It cooled into the dark, smooth, man-in-the-moon shapes we recognize today. But the far side's crust was just too thick for the lava to punch through, leaving those ancient impact craters exposed forever. Let's move on and see how this history builds, because for most of human history, that rugged far side was just a total blank on our maps. That finally changed on October 7, 1959, when the Soviet Luna 3 probe swung around the back of the moon and beamed the very first blurry photographs of the far side back to Earth. In 1968, the Apollo 8 astronauts became the first humans to witness it with their own eyes. Fast forward to January 2019, and China's Chang'e 4 spacecraft made history with the first soft landing on the far side. And just this year, in June 2024, the Chang'e 6 mission successfully returned humanity's very first samples of dirt and rock scooped directly from the far side's Apollo basin, a real game changer. Beyond simply filling in the map, the far side actually holds immense value for the future of science. Because it constantly faces away from Earth, the massive physical bulk of the moon acts as a giant shield, completely blocking out the relentless noise of Earth's radio, television, and satellite chatter. Astronomers literally consider it one of the most pristine, quiet spots in the solar system. There are active proposals to turn it into a lunar nature preserve and build a massive deep space radio telescope there. This would allow us to listen to the faintest whispers of the early universe without any terrestrial interference whatsoever.
The far side of the moon went from an impenetrable myth to a photograph map, and now it's a place we can actually touch and study. But it still holds immense secrets. It hosts the South Pole Aitken Basin, which is one of the single largest and deepest impact craters in the entire solar system. That alone holds untouched clues about the violent early days of our planetary neighborhood. It really makes you wonder, as we prepare to establish a permanent human presence on our closest celestial neighbor, what other ancient mysteries are waiting for us in the shadows of the moon's hidden half? I hope this explainer has completely transformed how you look up at the night sky. Keep wondering, keep learning, and I'll catch you in the next one.